Hi, in this video we are going to discuss two things. First one is central limit theorem CTL, and the second one is QQ plot. Okay, let's start dive into the central limit theorem CTL. Simply we will call it CTL. The first basic thing is we are using the CTL to convert the any distribution of data into the Gaussian distribution. Another most important thing is to find the mean of the population data. Sometimes it is difficult to find the mean of some population data. That time we can use the central limit theorem to find the mean of the population data. These two are things we are going to discuss this video. Let's look at into the central limit theorem. We will get some intuition firstly, then after we will see one example to get more understanding about the central limit theorem. For suppose let us consider data. X is a data. It's a population data. Population data. Population data means it's a very huge data. Okay, and then we will take a sample of data from this. X1 is a sample data from the population data. It must be greater than 30 points. And similarly, we will take the sample. We will also the number of points must be greater than 30. Similarly, we will take x number of samples. Okay, xn, and this is also greater than 30. Every sample data content greater than 30 points, and for every sample set we will take the mean, and the mean we can represent x1 bar, and for the x2 sample we will take the mean, and that one also represented with x2 bar. Similarly for all the things, and for xn we will get xn bar. Okay, now these means are in the Gaussian distribution. The means that we will get from the sample data is in a Gaussian distribution. This is the first thing we noted, and the second thing, and here the mean we will get mu. Okay, and the variance that we will get sigma square by. You can think why the variance is like this. We are for suppose the x is in the distribution of z, and the mean of the distribution is mu, and the variance is sigma square. By applying the central limit theorem, we will get the Gaussian distribution or normal distribution with the mean mu and the sigma square by n. Okay, here these two are same. These mu values, that means will be same, and the variance that we will get by the variance by n. By this way we will get the mean of the population data. That's the next thing we are seeing discussed before. Okay, let's go into an example to get more things. For suppose we want to find the average height of the Indian population. Okay, for example, x is the population data. Okay, and we have to find the heights of 130 crores people, because in India now I think nowadays we have 130 crores people, and take the average of this one or mean. This will be the mean height of the Indian people, but the thing is to find the heights of 130 crores people, it's not easy task. Okay, In this case, we can use the center limit theorem. By applying the center limit theorem, okay, X is the population data. From the population, we will take the sample of peoples. Okay, we will consider X1 sample. Suppose 30 people we will take randomly from the Indian population, and we will take the mean of those people, and we will get X1 bar. Similarly, we will take another sample of data greater than 30. Let's go with 30 only, and here also we will take the mean. Similarly, let's take up to 5 samples. X so 5. Here also 30. It's not to say 30. We can take more than 30. And X5 bar. Now we can observe that by taking the mean of these means, we will get the mean height of the Indian whole population. Okay. Now the average height is same as this one. Now you got the thing, I think. Here we can say that instead of finding the 130 crores people height, by just finding the 5 into 30, 150 people, by taking the only 150 people heights, we are got the average height. This is the beauty of the center limit theorem. Now let us discuss about the QQ plots. QQ plots. QQ plots is the one of the graphical approach to find the distribution of the given data. This is the graphical approach. This is a graphical approach. We have statistical approaches like KS test and A/B testing. These two things we will discuss in the next videos. Now let's go into deep dive into the QQ plots, how we can get the distribution of the data. Okay, for suppose X is the data, we want to check the data is in Gaussian distribution or not. For that we have to take Y also, and Y must be in the Gaussian distribution. Gaussian distribution. Now X is the data, and here's the points X1, X2 up to 500 points are there. Let's consider. And y is in Gaussian distribution. The X distribution we don't know, and Y distribution we know already. Here let's consider y1, y2 up to y400. No problem. In number of points will be different. So, and here we will find the percentile values to the X and Y. Okay. For the X, we will get the XP1, XP2, so on, XP100, because the highest percentile value will be 100. That's one only. Then similarly for Y, YP1, YP2, YP100. Okay. Now let us draw one thing. Now if X and Y are in the same distribution, okay, if X also in the Gaussian distribution, suppose, then we will get a straight line here. Okay, we will get a straight line, and the XP1, YP1, XP2, YP2, YP100, XP100. What if this is not straight line? If we get the line is like this, okay, then it represents these two distributions, sir. not same. And is anything like that will get like this, or we have some bending in the data. Okay, it was still like these two are not in the same distribution. Like that, we can check a distribution is Pareto distribution or skew distribution. Anything we can find the X distribution. Okay,